We are going to solve assignments today. Couple students came to my DM reporting to me some things that have been very difficult to solve. So I deemed it fit that I should resolve it so that they can move on. So the first assignment here says that I believe you can see very clearly. It says a particle moves with simple harmonic motion if its acceleration in meter per second is 100 times its displacement. Find the period of the motion. All right, now we are asked to find the period of the motion, which is t. But for the problem is that its acceleration is 100 times its displacement. So how do we go about that? All right, so there's this formula. First of all, write it as a equal to w squared in simple harmonic motion. If you've not done that, you should go and review that. We can call this our equation 1. And I will now come again and write a is equal to 100 times its displacement. So this becomes our equation 2. Now equating equation 1 and 2, I'm sorry I won't have time to actually explain everything in detail because it is going to take a lot of time. So you can later ask me on my Instagram page, on my Instagram or Twitter, or if you want to chat me up on WhatsApp 08111318968. I attend to students or problems. So if you're getting this video for the first time, we are all welcome to Explicit Fees Academic. Alright, so this is the assignment. We are getting question 1 and 2. So when we do that, we're going to have w squared a equal to 100 a. So a cancels this. So we are now having our angular frequency as w squared equal to 100. Now squaring this, we are going to have, if you square that 100, you're going to have w is equal to 10 radians. So we are asked to find the period. So I'm going to have to divide this, please, to manage paper also. So if you want to find the period here, it's very simple. We're just coming here to write t. Recall that t is equal to 2 pi all over w, that's angular frequency. So t here will be equal to, you put the value of pi, 2 times 3.14 all over 10. When you multiply 2.14 over 10, let me use my calculator here. My answer is 6.28 divided by 10, which should all give you 0.628 seconds. So our period, so the period of the motion t is equal to 0.628 seconds. So we're done with that. I believe you can see it very clear. Let me take it down a bit. I believe it's very clear. Okay, so we can move on, right? All right, let's go back to the second one here. Let's go back to the second one. The second one says sorry, I'm trying to make it look clearer. I'm doing this assignment at night so that if you're getting this video, you can copy it and help yourself out. Okay, the second one says here that an object moving with simple harmonic motion has an amplitude of 5 centimeters and a frequency of 50 Hz. Calculate A, the period of oscillation, B, acceleration of the middle end, and C, velocity. So we are asked to find 3 things, and as such, if you want to solve problems in physics, you don't just go on start solving and then do whatever you have to do. The first thing, you have to list out your data. You list out the data very well. Okay, so we're just going to draw our line here so that we could solve on both sides and get it more clearer. I believe you can see the question very clear. So what do we do now? Very simple. Very simple. We are going to list our data given that F is equal to 50 Hz, A is equal to 5 centimeters. What is A? A is amplitude. A is the amplitude given by 5 centimeters, which you convert, you have to convert it to meters. And if you do that, you're going to have 0.05 meters. They are done. So those are the parameters given in the question, I believe. So yes, that's correct. They're given frequency. And so now what are we asked to find? We are asked to find the period. So A, we start with period T will be equal to 1 all over F. So what I'm going to do now is just to substitute in the values and solve it. So that we are going to have 1 all over 50, which is equal to 0.02 seconds. We are done with that. I use my calculator down here so that I will not take much time. Okay, so let's move to the number one. B. We have, let's say, if you find what acceleration, right? So we are asked to find velocity, acceleration before velocity. So acceleration of the body A is given by an equation in simple harmonic motion, AW squared. That's amplitude and angular frequency. And we also know that, recall that W is equal to 2 pi F. So if we do this, we are going to have something. So we are going to put in the values here, and it's going to make complete sense. 2 times value of pi is 3.14. I believe you know that. 3.142. Okay, times the value of F is given from here. F is 50. We put in our 50. Now, when we now multiply everything out, it should be giving you a random figure of 314. That's what I'm using calculator down here to do. 314. That's your answer. And now you now go back to this A. We are asked to find the acceleration. So our A will be equal to 0.05 times whatever is inside here, 314 all squared. So that we are going to have. So if you now play with this, if you now solve this, you are going to have 4929.80 meters per second squared. Okay, so we are now asked to find the last one. That's the velocity. We are asked to find the velocity of the corresponding instance. Okay, the velocity here, the formula for velocity in simple harmonic motion, they all, if you have velocity, they all mean the same thing, but in different concepts of physics, they have different equation of expressing them. You can't use the same velocity you are using in describing motion of a body. In Newton's this thing to express the same one. They all mean the same thing, but the parameters used in describing simple harmonic motion, circular motion is all different. So that's why we have to look at them and consider those things. So the velocity here, V, is equal to AW. So when you now put this everything, you're going to have 0.05 times 314. I believe you know where we got this, our 314. If you go back here and check what we did here, we got our W value here, and our A 0.05 we are having here is coming from what we converted amplitude from 5 centimeters to meters. So I believe you have gotten everything there. So from here, we equal to 15.7 meters per second. And this is done for this question. Just take a look at the question again and check out the solving procedure. The video I did here was just for people to understand how to solve problems like this, related problems like this as well. So you just have to know the formula. Formula is quite simple. Anytime you hear simple harmonic motion, you should be able to know the parameters given and those equations to use so that it won't get complicated to go and use a different formula in solving it. The moment you start your simple harmonic motion, then we are talking about angular frequency will be there, period will be there, frequency will be there. So by the time you start noticing all those things it becomes simple for you. Okay, so this is the second one. We finished off with the second one. Okay, let's see how we could solve the last one. Okay, no, I think there is one more. Sorry for that. There is one more. Let me take it closer to the light. The question says here, an elastic wire extends by 1.0 centimeter when the load of 20 grams hangs from it, when a load of 20 grams hangs from it, comma, what is its additional load? What is the additional load required to cause a further extension of 2.0 centimeter? Okay, so we got a question here for us to solve. They're asking us what is the load required for you to cause a change of this centimeter. So let me just draw another line here. Sorry for that. Okay, now I told you earlier that if you are given a problem, you have to list out the parameters. So given x1 as equal to 1 centimeter, if you convert 1 centimeter to meter, to be equal to 0.01 meter, and s2, that's the initial extension, and this one is the, after it's been extended, 2 centimeter will be equal to 0.02 meters, and m mass will be equal to 20 grams, which is equal to 0.02 kilogram. We are converting it to the normal units used, so that you won't get figures that we aren't supposed to get. So you have to convert it. After checking the parameters, you check the units given. That's why if you have been following my YouTube, you see that I did something on unit and measurement. I'll be dropping that video very soon. On Monday or Tuesday, you'll be getting that video on my channel. So if you've not subscribed yet, just always subscribe and click on that icon button, because most times I do live class without telling anybody I'm doing live class. So it's only for the lucky ones that are subscribed and they have clicked on that icon, that will be notified that there's a class going on immediately to jump in. And those classes, most times they are not even for free, but if you can get hold of it immediately and join, I'm not stopping anybody. It's only for the lucky ones that can jump in. And most times after the class, I'll do lock up the videos for some specific peoples that have enrolled for the class. So if you are getting the video, it's a privilege to you. So maximize it very well. Maximize it. All right, back to it. We have listed out the parameters given. I believe it's only 3 parameters we are given, but we are going to solve a whole lot of stuff here. That's it. Okay, so let's see what we're going to have. So, of course, there will be gravity G, because we are dealing with Hooke's law, and since it's hanging, so definitely it will be under the influence of gravity, as in gravity will be influencing it. So we should take that into consideration. So now we know that the formula from Newton's second law, F is equal to mg. You know that already. Now substituting the values into this, we are going to have F as equal to, that's the second, 0.02 times 10. When you do this, all you are going to have 0.2 Newton. Now the expression to calculate the spring constant, the expression, that's a formula in calculating spring constant in Hooke's law, is given as F equal to kx, where k is the spring constant. Now substituting in the values in here, we are getting our G, our F as 0.2 Newton. As I said earlier, I've calculated this using my calculator down here. We are going to have 0.2, but please also take your time calculating it so that you won't operate in errors as well. We're going to have 0.2 equal to k times 0.01. That 0.01 we are having here is for the initial, this x1 we are putting in here. So when we do this, our k, the spring constant, will be equal to 20 Newton per meter. Okay, we are making progress down here. We're making progress. Okay, so now we know of this. We know of this as well. I believe so. Yes, we know of this and we know of this. This equation 1, this equation 2. Now equating equation 1 and 2, equation 1 and 2 is very simple. All these things, we are going to have mg, which is equal to kx. But in this case, we are given two values of x, one value of m. So what do we do here? Yes. In this place, m is changing. So we're going to have m1 plus m2 close bracket G is equal to K x1 plus x2. Now we are not going to substitute in the value, so we are going to have 0.02 plus m2 10, which is equal to 20, 0.01 plus 0.02. Okay, I believe now it's not making more sense, right? We've now put the value of m1. M1 was given, but M2 was not given, because the question there, we have to find the mass. This is the equation. Look at the equation again. Look at the equation again, please. I will give you like 5 seconds to process the equation before I do the final solution. Let me take it up here. All right, so that's it. So we are now solving it now. So from this point now, what we can do, we have to proceed. We have already gotten this. What we are looking for, this m is what we are looking for. So we are going to multiply it all. The operator from inside, are going to have here 0.02 times 10. 0.02 times 10. Someone should work on that. I believe there's an error here. 0.02 times 10 to give you, I think, 0.1 plus 10m2 will be equal to, first of all, operate what is inside the bracket here. First of all, operate what is inside the bracket here before you now proceed. Here will be 0.01, 0.02. Okay, so when you do this, you're going to have here 0.02. So 20, 0.03. If you add them together, now if you multiply them together, you're going to have 0.6. Okay, so now let's take this other side. 0.6. Please carefully. Now we are having the 0.6. Now we're going to, this is what we're having last, 0.1 plus 10 meter. So plus m2 is equals to 0.6. We take this to the other side. So we are going to have 10m2 is equal to 0.6 minus 0.02. So m2 will be equal to 0.4 all over 10, which is equal to 0.04 kilogram. I don't know. I think there must be a mixed up my calculator mistake I did there. But anyway, so that I'll be time conscious here. Later you can check this particular one with your calculator, but the formula I'm using are all correct. Well calculated. Check it very well. Check it what we did it very well. Okay. We are going to the last one. We're going to the last one. Okay, this is the question for the last one. That's the question for the last one. It says here, the last one, this question said that a 3.0 block is attached to a spring with force constant of 150 Newton per meter. The block is given an initial velocity in the positive direction of magnitude V0 equal to 12.0 meter per second and no initial displacement. Find the amplitude, frequency, and so on and so forth. So let me take it up again. It's very, very clear. I believe you can see it from here. Okay, I'm taking it down now. You can pause it and view it very, very well. Okay, now let's solve this. Let's take a new sheet of paper. So that one is already finished. Let's take a new sheet of paper and solve this one. Write our solution. We're going to write our solution before we continue. As I told you earlier, before you do anything in physics, you have to list out those questions. You have to list out those parameters given before you move on. So what do we have here? We are given m as equal to 3.0 kilogram. We are given K, force constant of 150 Newton per meter. V as equal to 12 meter per second. So I, that's W, is equal to square root of, sorry, I'm being fast here. That's the parameters given. Now, what are we asked to find? The first thing we are asked to find, let me check what we are asked to find. We are asked to find the amplitude. We are asked to find the amplitude. It will take us some processes before we finding the amplitude. So we have to use some corners. So the amplitude. So we start from the angular frequency is given by the root of k all over m. If we put in the formula, the parameters, we are going to have 150 all over 3. At the end of the day, if you work on this, W will be equal to 7.071 waves per second. No waves. Sorry about that. Okay. So we now have our A amplitude to be equal to W V all over W. The original formula for this, let me take you back. I'm trying to catch with time. V is always given, that's the velocity of simple and body motion. It's always given by V equal to WA. That's the amplitude and the angular frequency. This is what describes a body oscillating. Alright, so from here we can make A the square of the formula, that is the angular. So that's the amplitude. So our A will be equal to V all over W. Now if we now put the parameters of V here, we're going to have 12 all over W is all over what we got here as W, 7.071. So if we now work with that, we are going to have something here. Our answer is going to be 1.697 meters. So that becomes our amplitude. As I always say this, you can always check this with your calculator to see what you're going to have at the end of the day. So we are moving on. So B, we are asked to find the, let me check. We asked for the frequency and the period of the system. So what will be our frequency? Frequency F is always given by half 1 all over 2 pi bracket k all over m. So now we are putting the parameters inside. We are going to have 1 all over 2 pi bracket 150. That's the values all over 3. We are going to have 1 all over 2 pi 7.071. So at the end of the day, if we work on this all, our answer is going to be 1.13 hertz. As I said earlier, always check them again. So to find the period T, the formula for period T, you just find the inverse of this. Our formula now will now invert to be inverted 2 pi bracket m all over k. If you work with this, you're going to have 2 pi bracket 3 all over 150, which is equal to 2 pi 1.115, and our answer is going to be 0.723 seconds. Please check that out later. And what we asked to find the C, so that we find the phase angle. We know that we are given velocity V is always given by expressed by you differentiating displacement. So if you now do that, we are going to have WA sine WT plus, this is the phase angle here. So the phase shift or the phase difference, shift. So assuming this is 0, our V will be equal to minus WA sine phi. So our sine phi will be equal to V minus V all over WA. Our velocity, if you check we have a parameter of velocity, which is 12 all over WA. The parameters of W is 7.071 times the parameter for A, that's the amplitude what we calculated at first, was 1.697. At the end of the day, we are going to have minus 12 all over 11.99, which can be 12 at the end of the day. So sine phi will be equal to minus 1. If you divide this out, you give 1.000 before any digit. So we randomly keep it as 1. So finding the phi will be sine inverse of 1, of minus 1. So our answer will become minus 90 degrees. So that becomes our phase angle. That becomes our phase angle. Yeah, we're making progress here. So the last one, that's the D. The last one is the D. We are asked to find, I believe there is more to this. There is more to, let me check that question again. Okay, D says that the total energy of the motion, and the E from the question. Yeah, I believe you had the question. You should check the question very, very well. The E says that you should write an expression for the position, velocity, and acceleration as a function of time. But first, before we go there, we have to find the energy. We have to find the energy. So how do we do that? The energy for potential energy, U is equal to, let me draw a line here so that we can still write it here, and you will see the other things we've done before. Okay, is equal to 1 all over 2 mv squared, which is equal to 1 all over 2 this v. If you take, I'll still write out the function, but let's just take it here, squared sine squared wt omega this. Okay, then for kinetic energy, before we could find the total energy, I don't just go and write the formula and then we start solving. I want us to just have a background knowledge of where it's coming from, so that we know what we are doing. Cos squared omega t plus this. So okay, this is it. So now we are now asked to find the total energy. So the total energy of this, is going to be, adding the total, as E will be equal to K plus U, which is equal to half MW squared E. If you add in these two guys together, this is what we are going to have, E squared sine squared omega t plus phi plus cos squared omega t plus phi. Sorry for that jargon I wrote there. Okay, we are making progress here. So at the end of the day, from our sine trigonometry sign, that sine square theta plus cos square theta is equal to 1. I believe you know this. So all this will become 1. So the total energy will be equal to half m omega squared a squared. All right, so this is the total energy of the motion. That's the formula we're going to use, total energy of the motion. All right, so having done that, we're going to write E as equal to half, putting the formula, M was 3 times 3. We are having W squared. So W here was times 7.071 squared times our amplitude. The value of amplitude was 1.697 all squared. When you now play with all this, you get an answer. Okay, so that is it. Sorry, I don't know what's wrong with this calculator. I think it's malfunctioning, so that I will not give people the wrong answer on this. I'm trying to hit it. Oh, why is it not working? All right, please, we're going to stop it, but this is the solution for it. Put in the values, multiply everything or square it, and then divided by 2. You are going to get the energy in joules. Let's move on to the last one. The last one said that we should write an expression for the position, velocity, and acceleration. That was the last thing. Oh, sorry, that's the last thing we are asked to write. So what do we do? Very simple. For a motion given by this is the this for position. Okay, and for velocity as a function of t, they all depends on t. That's differentiating this with respect to t using normal differentiation. If you have not watched my video on differentiation, please do so. It will help you to understand how they got this. They differentiated it with respect to t, and what they got here as the output was minus, because when you differentiate this, it becomes division of cos is minus. I believe if you have not watched my video, you should go and watch it too, so that you will know what I did here. Now, for you to get acceleration, we have to differentiate it with respect to t again. So acceleration with respect to t will be equal to t minus w squared a cos wt plus phi. So here becomes our solution. Please, this is what we got. It's only this I've missed out because calculator was malfunctioning, so that I will not get the wrong thing. Even I will still I'll still advise people to as well. Please still go back again. Go back and check everything what I've done. Go back and check everything on and learn the equations I'm using to solving all these things all. Alright, so we are going to stop here for today. This is the assignment I was able to do. I've done for some students that met me. If you're getting this video, I believe even though you are not involved, you should be able to learn one or two things from this. You should be able to learn one or two things from this. We've solved a lot. All right, so we're going to stop here. If you've not subscribed to the channel, do it to subscribe. There's so much you'll be doing. There's so much we're going to be doing. Subscribe to the channel. Hit the icon button. Subscribe to all our videos and watch other subsequent videos to learn what we've done so far. All right, guys. I'll see you guys later. Bye. Okay.